So let's go a little bit more from Slovenia to the northeast, to Hungary. It's a big pleasure and honor to have Lipót Répászky with us, the Managing Director of the National Audiovisual Archive of Hungary. And he will bring another aspect to us, another different aspect. It means audiovisual archives, what can be done there with artificial intelligence and machine learning. So the floor is yours. We are looking forward to your presentation.
Thank you, and welcome to everyone who is joined here in Alicante and from home. So let me introduce myself. My name is Lipót Répászky, and I have been responsible for the National Audiovisual Archive in Hungary, for shortly NAVA, since 2014. And I am an engineer, and this means that I usually speak more technical detail. But of course, today I will present to you only one project without any deep IT details. So, because my aim is to show you how AI works in action in our photo archive. So, the NAVA, just wait a minute because I think something wrong. Could you start my presentation? It doesn't working. So the NAVA has been a centralized archive with photo, TV, radio, and news department. And this last archive was founded before the last century, and the youngest department, the NAVA, is responsible for those since 2006. The archive alone is a relatively large department, and with up to 200 workers, like archivists, engineers, and experts. And we are part of the Hungarian Public Television and Radio Organization. This is the MTVA. Yeah, thank you. So we are part of the Hungarian Public Television and Radio Organization. This is the MTVA. And so it means we have to support the production with materials. And all material then older than 10 days is archived. So it's a living archive with millions of documents and a huge quantity of materials. You can see the whole department on the frame. So in the next 20 minutes, I would like to demonstrate how we reduce our workflow time in our photo archive. For example, here is a picture which you can see on the frame. We know it's a square in Budapest, and at a guess, it's the 1930s. But what about the keywords? There is a crowd, there is a street scene, and we know that which square it is. So, and of course we know that it's black and white, but that's all. This is what a human archivist can do. It took 1 minute, but there was no deep information. But imagine that we have approximately 10 million photo negatives in our archive, and we are digitalizing 1,000 images per day. And we have 10 archivists, and they are able to describe and identify really deeply approximately 100 images per day. So I think it's really simple, because we don't have enough time to describe everything and identify everyone on the picture. We don't have the 400 years that would be needed to do this. So it's that is the reason why we use a time limit in our workflow, and we have to do something, because here is our workflow model, and you can see our problem too. What does the archivist do exactly? If you are an archivist in our photo archive, you have only 10 minutes to answer for these questions. For example, whether there is any violence on the scene, or it's inside or outside, what is the color space, the scene, and are any faces on the picture, and so on. So it's a time-consuming workflow, I know, but the most time-consuming workflow is to make keywords and describe the images really deeply with the most relevant subjects. And why are we looking for this answer? Well, we have to filter our images, because if we don't, it will be unsearchable. Let me give an example. So we have one group of images with street and crowd keywords, and if someone try to search for a scene or building in our photo archive, just click on the Show Only Places button, and the number of documents will be reduced approximately by half. It's really important to show the relevant images, and it's about the user experience. We don't have enough time to describe everything. We don't have enough time to create these filtering keywords for all digitalized images with human power, because we are digitalizing more than we are able to describe those pictures. So this AI, which we use, is able to reduce the workflow from 10 minutes to 2 minutes. So when we started to use our AI tool, which the Azure Cognitive Services by Microsoft, the first step was to create the automated keyword method. Our aim was to have an automated system which can detect the objects on the picture and describe the most relevant images, describe the most relevant subjects. And this AI is able to detect the adult content, the dominant colors. It can detect indoor or outdoor, or landscape or portrait mode, and the default filtering keywords. It can detect only the faces, and on the picture. It doesn't know who is on the picture. It just detects faces, the emotions, and ages, and these ages will be important information, but I will speak about later. So what can we do after using this AI? We have to confirm the relevant keywords which we get from the AI. Or ignore them, of course, if they are not important or not relevant. So you can see the confirmed keywords with bold, and you can see the measure of confidence with percentage on the frame. So we are just saving 2 minutes from our workflow, but we have more time to answer the question with human power: where, when, and who is on the picture. Of course, we have to add the missing keywords which the AI didn't detect some reason. In this case, or our missing keywords might be the fountain on the picture on the right-hand side, and the horsepower tram in the center of the image in the crowd. We don't train this cognitive vision because we are just use the default of 1,000 objects which this AI is able to detect for the standardization, because we would like to use only the standard objects at the moment to help the searching method. But what about the faces? Our archivists must use question and sentences when discussing together who is on the picture, who is it, and the other archivists say, oh wait, I have detected this person 100 images ago, he was a leader on the right-hand side. So let's just take a moment, and how do you identify a person? For example, I can help you. You can try to compare the known and the unknown person like a huge, well-known memory card game. But I have some problems with these games. First of all, nobody knows everybody. And the second thing, the oldest images, for example, from the early 1920s, weren't well documented because the original photographer's description was partially destroyed during the Second World War, or simply missing from our paper-based database. But what does it mean in this case? If you identify, if one archivist identify a person at once, and different archivists are continuing the process, might be detect the same person again and again, and this is such a waste of time. So we have to use a super archivist who can detect anyone and knows everybody. And imagine that you have a new picture from the digitalization department, and with 2 faces, where in this case you don't know who the person is on the left-hand side. The person on the right is János Kádár, the communist leader and the general secretary of communist Hungary. You can guess that the picture was taken in the mid-60s, so the unknown person might be a commander, like part of any military group. And it's a really important information. This is the first information about this person. We have to compare the face of known military people with this unknown face. And that is what the AI does exactly. But really many times faster and faster than the archivist. Here in this frame you can see on this frame the group of people which we have already trained by AI. And what does pub mean? When we defined the AI, we had to give it a name, and the best result was public, because we want to use this AI to detect only public figures. And a couple of months later, we used as a pub for shortly, and it sounds like a tavern. You know, it's a bit like entering a pub with a photo and saying to the crowd of drinkers, "Hey everyone, does anyone know who is on this picture?" And that is the reason why we say pub. We have really a lot of pub in our archive. For example, military pub, politicians pub, dead people pub. It's really funny. Pub for children's, pub for actors with masks, and so on, because of the AI performance. It's a really important thing. And you can see the military. You can see the military pub in this frame, and you can see exactly that moment when the AI sends a response. It has answered your query about the picture with the unknown face, which you uploaded to the AI, of course. First of all, at the top you can see the first two relevant answers with the highest confidence percentage, and you can see the least relevant least relevant answer with just 1% confidence. All in all, you have 1 to 10 suggested person IDs. It depends of the pub. It depends of the AI. Like a person ID 1, 2, 3, which you can see to the green box. This is the closest answer. What does it mean? The AI doesn't know who is it. The AI just suggests and compares and suggests which faces or which face group is the most relevant and which person looks most like the other person. It only 5 seconds. What can the archivist do with this information? The archivist has a responsibility for validating the person, which the AI suggests. The AI has identified the person ID with the most relevant results, and of course we have a database with real names and person IDs, of course. But the archivist has to decide whether the AI is right or not. And this is the human factor, which is the most important moment. If the human says yes, it means that they have to train this AI. They have to train this person with this new face. So they have to add a new identified face for the person ID. We have a database with person IDs and real names, of course, separately because of the GDPR issue. So we have to be very careful. So we store the person IDs on the cloud, and that's all. And we store the person IDs and real names in our local storages, in our local system, because we are the responsible for the GDPR compatibility. you know, it's a living archive, so we have to be very careful with public figures and actors and so on. So the most important thing, we don't train the AI with personal information. What happens if the AI gives the wrong answer? The AI always gives the right answer. Perhaps the human has mistrained the AI. It's a really huge danger for us, because we had to train the AI many times because some had a mistake and mistrained our AI. So let's go back to the title, and how many faces does a person have? Based on our knowledge and our experience, we can say if you want to train the AI, if you want the best results, you have to make 2 or 3 different personalities for one person. Like in this situation, which you can see in the frame, you can see the same person, Mari Törőcsik, a well-known Hungarian actress. But if you try to ask the AI, is this the same person? The AI, the answer will be no. Why? Because our face changes decade to decade, year by year, so we don't look the same at the age of 20 and 80. And how does it looks like in action? I have made a demo, a recorded demo, but feel free to use it by yourself with this QR code, and just download the source code. And I hope starting, yeah. You can see that you have got a new picture from the digitalization department, and at the moment we are working with the AI, so we don't know anything in this picture. Here is the most relevant keywords, and we don't know who is on the picture. Okay, we have to define only once. For example, in this case, John Paul II, and we define who is on the picture. And if you have got a new picture from the digitalization department, the AI working again, and the result is we know who is on the picture, and you can see the confidence. And it's the most important because that is the basic information. So to conclude, the answer is if you try to train the AI, the best practice if you use 20 and 2 or 20 faces per personalities. So each person has between 20 and 30 different faces. And I think that's all. That is our photo archive, and that is our new AI tool. So I think it's good. Thank you.
Oops. Thank you very much for that highly inspiring presentation. I think it was really interesting to see how AI can concretely be applied on photos, and also what effect it has on your work. So also that it was quite interesting for me to learn that the workflow was reduced from 10 to 2 minutes. That's really impressive. 5 times.
Yeah.
That's
so that is our aim. That was our aim. Our aim. Yeah.
That's really incredible. Any questions in the audience?
we are digitalized approximately 300,000 images until today, and approximately we have more than 10,000 different people, different person, and of course it means 30,000 personalities in our archive. So if you want to try, just click on this, use the nava.hu URL if you would like to use in action, because our photo archive already use this algorithm. So feel free to use the source code too, because it's free.
Thank you very much. I think we will do it with big pleasure and with huge interest.
Thank you.
So, thank you very much.
Thank you.